Okay, we should be live on every platform right now.
All right.
Yeah, let me just make sure this actually works and that people can hear us. I want to see how long it takes before I get messages telling me I'm doing everything wrong.
Doing it wrong.
Yeah. Okay, we are live on LinkedIn and YouTube and Twitch. We are not live on Instagram or TikTok. I did hear there are only 44 more days of TikTok until the TikTok ban. Did you hear about
really?
that?
It's official now.
I mean, it seems like it. I don't know. We'll see. So if there was ever a time, to get on the bandwagon, it's right now. So if anybody listening has been around with Endor Labs or watched our content for a little bit, you might have met me before. My name is Ron. I'm on the marketing team here. Andrew actually joined us pretty recently. So Andrew, can you talk maybe a little bit just about your background, and then let's jump into fixing?
Yeah, definitely. So yeah, I've been at Endor Labs about a month now on the product marketing team. Before that, though, I worked at Nginx. You probably guys might know it as the open source web server. Did some API work and API security work there as well. And then last couple of years, been at 1Password doing developer security work, particularly around secrets management. So super excited to be here. Really excited about the approach that Endor Labs is taking to actually fixing things, which is what we're going to be talking about today, rather than just bearing you in alerts. So
yeah, our focus really over the past 2 years has been very specifically around this concept that the future of code security and the way we think about code security has to be more focused on actually fixing things rather than just finding things. In a little bit, we'll have one of our security engineers, Matt, joining us, and we'll be spending most of our time just like running around the demo, actually fixing things. But we wanted to talk about it a little bit before. So the foundation of what Endor Labs does, or where we started, really was in the world of software composition analysis and SCA. The problem really started with our two co-founders. They led large engineering teams at large companies, and they ran into this issue where either you flood your engineers with alerts, with security alerts, in the pursuit of checking the box of you did the security scan. The application security team on their end, they were sort of set up for failure, right? Because they didn't really have any other tool than something that would flood the engineering team with alerts. And it came to a point where one of two things could happen, and both of them were bad outcomes. One, either there was a step in NCI that says, remove the manifest files, right, from the packages, and then all of a sudden 0 vulnerabilities, right? Because that's how most SCA tools would work. They will scan a manifest file. They'll give you all the vulnerabilities that are associated with the dependencies that are listed there. And that is the list that you see on the output. Maybe you can filter that by severity, but that's pretty much it. So that is where the need for prioritization originally came from. But once you do recognize, okay, I have a critical vulnerability here, I want to fix something, that's where understanding the dependence of that fix started to become an issue. So, for example, I want to fix, I'm using Jackson Data Bind, I want to fix something. They would go on Slack and they will say, hey, who's using this package? I'm going to do an update. Will anything blow up? And that was actually the process. And in a lot of companies, you see it is managed through Slack, through spreadsheets, even with some of the most advanced tooling out there. So with that and the fact that, according to GitHub, 80-90% of modern code bases are open source. If you look towards the future and generative AI and AI generated code, most of your code in your code base is going to be things that you didn't author, but that someone else authored or that you depend on. That really where the need for reachability-based SCA, deep prioritization, and a code security platform, honestly, that helps you go home a little bit earlier on a Friday. That's really where that need came from. So that has been the core of what we do. Very recently, the latest kind of innovation or the latest step is really the move from finding into fixing, right? So we've been very focused on, okay, let's find the most critical risks and vulnerabilities in your open source software, in your container-based images, in the secrets that you might have in your code. And now the next phase of that is, okay, let's make sure you're actually also prioritizing the risks. So Andrew, can you talk a little bit about maybe just why fixing software is so hard, and then from that we can take it from there.
Yeah, and I might actually go ahead and steal the screen here for just a second to show a snippet from a little white paper we've been working on here.
Mm-hmm.
Oh, of course, did this in the. There we go. Okay. So, the way software is built, your developers may have picked an open source version, let's call it 1.1, and use that in their application. The problem is, in that version, there may have been a vulnerability, but, security researchers, for example, may not find it until months or even years later. And at that point, the open source project has gone on, right? So they've made other updates to add additional improvements, functionality. And so they go ahead and patch it up here in 1.4. And this makes causes a huge issue because you have all these breaking changes. And so if your team, wants to move from 1.1 to 1.4, they have to actually do all of this work to fix it. And that's just, for a basic, single dependency upgrade. Like you're moving from, one dependency to another dependency. Gets a lot messier though, because the way open source works is all your dependencies have their own dependencies, and we call those transitive dependencies. And so now you might have, this whole mess of upgrading from not just this one, dependency, but all these transitives that maybe have different versions. Maybe one's using 1.1 and 1.2. Basically, you end up your software is going to break, and your engineers are going to have to spend weeks, in some cases months or even years, refactoring all this. And that's kind of the basic issue. But even beyond that, even if they are able to upgrade from 1.1.1 to 1.1.2, things still break. And actually, I was talking with our researchers and a couple of our engineers this week, and they pointed me back to the State of Dependency Management report that Endor Labs did earlier this year. And we did a literature review, and one of the findings actually was that even when you're doing basically what we call a patch, so that kind of really minor security patch, about 75% of the time, there's still breaking changes in that. And that's even with, what in the industry we call semantic versioning, right? The idea is that in theory, breaking changes are only supposed to be in that major version where you see that 100% breaking changes. But even really, really small changes introduce regressions and break things. And that means your engineering team is spending a lot of time running down and chasing things. Anything you'd add to that, Ron?
Yeah, no, I mean, I think you nailed it. And I think that it is probably the reason why, at least in some cases, there's some of these packages that you hear over and over. You hear about Jackson Data Bind, you hear about Spring, and some of these where there are so many different versions, and you want to get to a point where the reason that you're upgrading is for functionality and not because there's an application security engineer who's on your back about it. And also that can end you up in a situation where it's been years and no one wants to touch a piece of software because upgrading it is going to be so incredibly painful. And the way we look at it, there's essentially two paths to how do you fix that problem. One path is find the path of least resistance. If you do need to upgrade, and maybe it could be a minor version or a major version, but whatever it might be, maybe there's a version of that upgrade where it doesn't have as much breaking changes, or patching is the other way. Can you help us kind of break those down, upgrade impact analysis and patches?
Yeah. So upgrade impact, again, with upgrade impact analysis, we're actually using all the rich data that Endor Labs has about your app through using our SEA, right? So that's kind of a really key starting point, is that we actually have a lot of information about how your app works, that we can actually make these recommendations about where you should upgrade. And we actually kind of rate that based on risk, based on the context we know about your application. So we're telling you, this upgrade to, 1.3, for example, is low risk. Most cases you're not gonna have any breaking changes, and it'll fix maybe, 50% of your vulnerabilities. But you get to the next one, okay, if you go to all the way to, that 1.4, actually there's a really high risk of breaking changes. We'll flag that for you, and let you kind of make that decision about what you want to do. And so that you can start to have smart conversations with your engineering team. So it's not just, here's a vulnerability, go upgrade, and kind of leave it for them to do the research, try it out, find something breaks, and then have to go kind of hunt down what is actually broken. We'll kind of tell you, here's the risk, and we'll even show you where we think those breaking changes might be in your application, so that you can have a really informed conversation about what you want to take on. But we also offer you another route, and this is really important for organizations that need to meet SLAs or FedRAMP or something, where you're trying to have a mean time of remediation under a month, or even better than that in some cases, and that's patching. I'll talk a little bit more about how our patches work, but really simply, it allows you to actually patch that vulnerability so that your engineering team doesn't have to pick up the work right away. They can pick it up on their own schedule when they want to do that upgrade to the application, and basically let you stay safe right away. Oftentimes, like, obviously, if it's going to be a hard upgrade, that's a really obvious choice, but you might even want to do it on some of those easy upgrades, just so that you can kind of hit that remediation goal. And then again, work with the engineering team so they can pick it up in their next sprint, even if that starts maybe 4 or 5 weeks later, outside of your timeline. Another key benefit there is actually helps you stop those fire drills, right? Where AppSec is coming in, they're trying to finish a sprint where they're like deliver this big feature, and they have to put it on hold because the entire organization has to go fix this vulnerability. And that's, I think, another huge benefit of patches.
Yeah, and it can also have pretty significant compliance implications as well, because a lot of compliance standards will ask you to very specifically address vulnerability within a certain SLA, within 30 days, within 60 days, whatever the standard may be. But very often they will not specify what addressing it means. So we've seen customers either go back and say, well, here are the ones that we addressed because of reachability data. These are the ones that are actually reachable from our first party code and that have risk in them, and here's how we address them. But the patches can also help you check that compliance checkbox while also actually reducing risk, right? Without we'll see it in a little bit once we get into remediating. But the interesting thing is that usually the choice is between either I refactor an application to account for all of the breaking changes, the compatibility issues, which might be, a 50,000 lines of code project, versus do I apply this patch that then is 7 lines of code. Another perspective that I really like, that I heard one of our engineers talk about, that it really frees you up to upgrade when you want the functionality, versus upgrade because you have to, because that there's a security mandate. You get the security benefits, you fix the criticals and the highs with the patch, and then if you need to upgrade because of functionality, or if it's a longer term project, you're safe during that. Yeah. So how does it work, the patches themselves?
Yeah, I think one of the coolest things about the patches is actually it's taking the open source security fix that has already been developed by the maintainers and vetted by the community, and actually bringing it back to the version that you're using. We call that backporting, and it's something that like an open source maintainer could choose to do. Like, they could fix it in the most recent version and then try to go back to every single version. But a lot of times that's way too much work. You're lucky if you have 2 or 3 active maintainers on a project. A lot of times it may be one person that's maintaining that particular project, at least on a regular basis. And so really hard for them. But with Endor Labs, that's actually what we do, is we take that security fix and we bring it back to the version that you're using. And you might wonder, like, how on earth does that work? To put it really simply, like, first of all, we do an evaluation of the fix, kind of identify what's changed. We go ahead and start bringing it backwards, and we actually do our own upgraded impact analysis. So the same thing that you'd be doing, on your dependencies, we kind of take to the actual package, kind of look at that upgrade analysis, and then kind of identify where we can make that fix. Do a lot of testing, so we make sure that there are no API changes or anything that would be a breaking change. Do a ton of testing, and then actually provide it to you so that you can put it on your version. And There's really a couple easy ways. Like if you wanted to just try this out, you can pick one project, find a developer that you can work with, grab the, your SEA and, Endor Labs. And all it takes is you get an API key. You go into the package manager for that project, configure that project to use the dependency. So use, for example, tack Endor latest onto Jaxa data bind and rebuild the application in your patch. So very, very simple, on a one project basis. And then from there, you can actually, integrate with your artifact repository and kind of scale it across the organization.
What happens if, obviously I'm very biased and I'm wearing an Endor Labs t-shirt under this sweater, but what happens if you leave Endor Labs?
Yeah, so if you were to leave Endor Labs, first thing you should know is like any application that is already built and running would continue running. Like there's no immediate breaking change. The change would happen at build. And I think before we get into that, we might need to talk a little bit about like different ways of applying Endor patches. But in short, if you're using our auto patching method, all that would happen is you would fall back to the previously vulnerable version. Obviously, that's a problem. You would need to work with the engineering team to like scope that work and make sure you're addressing that. But your application would always work at any point. And even if you did rebuild the application with a vulnerable version, it would still be working because we're not actually introducing any changes. If you're kind of like, you can do what we call pinnings. If you pin to a specific Endor Labs version, so imagine it was December 6th today is when you pinned it on 2024. In that case, like when you try to rebuild the application, it would break and you'd have to remove the patch. But again, anything that's running wouldn't be impacted. So it's really easy, to add them and remove them as you need. Obviously, we'd love to see you keep working with us, but if you ever need to leave, your applications wouldn't be impacted. It's just the vulnerabilities would come back, and you have to make sure you plan that work at some point as part of your transition.
Yeah. Can you talk a little bit more about the manual patching versus auto patching?
Yeah, so high level, we have two methods. So manual is kind of that first example I gave where you're actually kind of going into every single project and every single dependency and applying the patch. Advantage there is you have a lot of control, and especially if you do what we call pinning, so pinning to that specific date of an Endor patch, make sure that that build is always reproducible, which for some organizations can be really important. Like you need that kind of audit trail. That's kind of one method. We have like a between method that we call using Endor latest. So instead of basically saying, Jackson data bind, Endor 2024, 12.6, you just use the Endor latest patch. And it's in between, so that way if there's a new vulnerability or we update our patch, you automatically get that in your application. So that's kind of that between method. But again, all of these methods require kind of engagement with the developer team, like on an ongoing basis. They have to maybe be in the code. Auto patching is actually completely different and makes patching essentially invisible to your developers. That way they're not being interrupted by it. What we basically do, you have your vulnerable Jackson data bind version. Endor just kind of replaces that automatically in your code, and they don't have to make any changes. It's applied automatically. The easiest way to do that, especially if you're trying to scale this across an organization, is through your artifact repository, right? So you add the Endor Labs patch factory as a virtual repository, kind of set it as the priority, and then that way, whenever you're inside Endor Labs, the dashboard, for example, you see this exploitable vulnerability, you can apply the patch, and it'll be automatically applied at the next build of the application and just supersede that previous version. And in that case, the developers don't have to do anything. It's done, at build time in the CI pipeline. And if you do another scan with, Endor Labs, it should actually be marked as resolved. And so advantage here is it's really, really easy to scale across the organization, all of your packages really, really quickly. The downside here is obviously it's not reproducible, right? And it's a little bit invisible to your developers in some cases.
In the automatic option?
Yes. Yeah. So again, because we're automatically basically replacing Jaxa data bind with the same version number essentially in the package, but it's suddenly our patch. Can't reproduce it because if our build ever changed, your package would change.
Yeah,
that's kind of that's the trade-off. But
I did see that with every patch that we have, and you can see this in the Endor Labs UI, we have the attestation that is packaged with it, the logs, the reproducible builds. So can you walk us through that? Just explain what those mean for customers.
Yeah, let me give me 1 second. Maybe actually see if I can pull up an example here, just so you can kind of see a little bit in the UI, and then I'll let Matt do a little more detailed job here.
Mm-hmm.
Okay, so yeah, if you're in here, we see, we have actually a patch available, and we can click and learn a lot more. And then we provide, I think this is what you're asking about, all this
Yeah.
information on the right here around the patch attestations. So what I was talking about before is like when we apply with auto patching, the patch is automatically applied, and your build may not be reproducible if something were to change, but you always have access to all the information about a patch, whatever version it is, through the Endor Labs interface. And so what we're giving you here is basically, how we built it, how we tested it, how we deployed it, and actually a build of the patch that you could download with all of our code changes and use any way you want. So quick
Yeah.
version. And hey, I think Matt joined us as well. So
Yeah, we had, by the way, 2 questions here. One, is it possible to share the white paper? Yes, pretty soon it will be publicly available. And do we leverage LLMs for this task of upgrading without breaking? Do we?
No, we don't. None of this is LLM. This is all based on visibility into your application. And then we are actually manually, like with our engineering team, doing the backport, reviewing it, and publishing it. So there is a human review process in it. It's not LLM. So you're not going to get hallucinations, other things like that in your code.
I like that we've come almost full circle on the AI hype cycle, where it's almost a bonus of this is, humans are involved with this. This is not just AI hallucinations. Matt, thank you for joining us.
Thanks for having me. Can you hear me okay?
Yeah, can hear you just fine. What do you think about our Endor Labs background, this whole setup? We're live on Twitch, Matt.
I love it. I absolutely love it. Finally.
Yeah.
What do you guys?
We were just talking about earlier how there's only 44 more days of TikTok left.
Is that really going to happen, though?
I don't know. That's what I heard. That was the sensational news headline I read this morning.
That's what you saw on TikTok?
Yeah, exactly. I did see that on TikTok.
You guys been talking patches?
We've been talking patches. Yeah. So we had put together this white paper that Andrew has been working on over the last few weeks that kind of breaks down how patches work, who they're for. So he has been walking us through it. And we wanted to dive into it, not just patches, but also upgrade impact analysis in general. So where do you want to start, Matt? What are we fixing today? And Andrew, by the way, hang out with us, or if you have other work you have to do, we will understand, but we will be here.
All right, I'll stick around for a little bit.
Yep.
Sweet. I just want to start fixing some stuff. Literally.
Let's do it.
That's what I'm thinking. Let me see, figure out sharing here.
Yeah, so you click on present at the bottom of the screen.
I got it.
I know you're an engineer, but this might be a little too advanced for you.
No, I've never used a computer before.
Yeah, first time.
Let's do entire screen. Why not? Yeah.
Just go crazy.
Right. Okay, good. I'd have do not disturb is on. Good. Make sure we're not disturbed.
Not showing us all of your secret stuff.
Some secret stuff, but not all of it. I can't be showing all of it. So kind of what I was thinking was, obviously we've tested upgrade impact analysis and doing it, but we can just demo all the live long day, but I kind of want to try legitimately just fixing things using upgrade impact analysis and just proving this actually is legitimately working. And I don't know, I just thought it'd be fun to kind of see what it looks like to actually fix something that's in a project. That's kind of my thought of what we want to go over today. So I'm just going to pick some projects here, and I have a bunch in my projects folder, and I'm going to let's start with an easy one. All right. I should already have this open in a terminal window. Good. So I have this nice little Java project. I've already scanned it in Endor, but let's do it again. Why not? Endor CTL scan. I'm going to do -n in my namespace. And what it'll show in a moment, and I'll actually go back onto the page here, the actual fixes that we can do. Let's do, that one's going to be finished soon, but this will be a good example here. So what I'm thinking is why don't we actually fix some of this stuff and actually use the remediation advice we give to people and actually like fix it.
So can you just walk through why this one is recommended? Like, what does that remediation option mean?
This recommendation here, here's what we're saying. We're like, all right, currently this version of JBoss Weld Core, right now we're on 1.1.33.final, but that has one critical, two medium, and one low. And we're going to give some recommendations. Like, this is the thing with fixing stuff, is like, sometimes if you want to fix vulnerabilities, you do got to make a major version change. This is why we're saying it's medium, because major version changes can be risky, right? We're not seeing any breaking changes using our call graphs. We have some medium confidence ones where we're saying, look, we see some indications that you could be using this. This is like a good one to try out to see if it will actually break code. And if it does, then it does. But if it doesn't, then that's even better, because we can actually upgrade it with confidence, and we can actually test it and do all that fun stuff. So medium risk is like, it's a little risky because it's a major version change in this example, but it could be, hey, there's indications of breaking changes, or maybe there's some nuanced thing that Java Maven pulls in as it's being built and as it's actually like going on, and it's a medium risk, right? Low risk is, hey, we don't see anything. We can definitively say, like, we don't see any breaking changes. You should upgrade this. Like, that's no problem. And then highs are, there are some breaking changes here. Like, we can definitely tell you there's some pretty nasty stuff that's going on in there. So let's actually go back
to the way we do that is a similar process to breachability analysis, understanding the path from your first party code to
that's
the
right.
vulnerability.
Yeah. That's right. So the call paths that we use, like when we first came out with them, we were using them for the vulnerabilities, obviously, right? This is what people wanted in SCA for years, and nobody could really do it well until Endor came along and started doing it really well. So what we did was we said, okay, we kind of nailed the reachability in the aspect of telling you, okay, this is the vulnerability that you're actually calling from your code. Why don't we just take those same call graphs that we generate and actually apply it to, well, if I upgrade, is this going to impact my code in any way? If I actually try to upgrade to this version using those same call graphs, will my code touch anything that's been added, changed, removed, edited, whatever? So it's a really fun fact. This was a hackathon project, like, geez, Ron, what, 2 years ago?
Yeah, that's where it started.
Yeah, that's where it started. And I think it won. I think it won the hackathon at our company. And we baked into the product. So if you're interested in working at Endor, you can build cool stuff during hackathons. It'll actually get into the product, which is pretty nice. There were other projects too during that hackathon that are built in, but I thought that this one was particularly really, really nice to actually showcase and everything. So let's do one that has like a lot more remediations. This is a pretty good one. All right, so ready? Let's just walk through the whole workflow. All right, I'm gonna grab my project. Okay, I'll grab my project, and I don't believe I have this one in here. I do. Okay, CD Acme monorepo. All right, let's go in there, and then I want to go ahead, just make sure that I don't have anything. They've added a couple things there, but that's fine. Oops. And let's actually try to do, let's scan this out. And we're going to apply these same kind of fixes here. So let's actually take a look at this list. This is a pretty good one that you should always try to fix, is log4j. This is a pretty good one where we're going to fix two criticals. This is
so original, man, fixing log4j.
I know, but listen, like, this is what one, like, thank you for calling me out on that. I hate using it, but it is the one everybody knows. Okay. if I'm like, oh, let's fix this in Flask, it's like different versions of Flask have different, vulnerabilities all the time. But like everyone should be fixing Log4j like all the time, or just use something else, or especially this older version of it. Like this has been exploited. CISA Kev, we have this information in here. This has been exploited in the wild. Like, this is not good. So listen, I use it for a couple reasons, but we'll fix more nuanced ones too while we're here. Why not? So let's actually open that one up in code, in Visual Studio Code, and that's wrapped up. But I want to take a look at what else we can fix here. Java ones are pretty good because you can just do it in the pom.xml. Pillow's a good one. We'll fix Pillow too. Pillow is for those who don't know, this is a component that like helps with images in Python. So one of these projects, like in our demo environment, that if people like sign up for Endor, they could actually scan like demo projects we've all built. The Python one is the Python video game one. That is my grad school SpongeBob RPG video game written in Python, and it uses Pillow to like flash up a Krabby Patty when you like make the Krabby Patty and stuff like that. So Pillow is an interesting component that just like helps you render images and stuff like that, and it's near and dear to my heart. I'll say, this is what I'll say for that. But for those who wanted some insider baseball, there you go. Okay, cool. So let's do Log4j first. So let me just open it up in code. Acme monorepo. Code's going to open on up. Let's go into Java. Now, let's kind of walk through step by step. As soon as VS Code stops yelling at me. All right. So Log4j core saying, hey, currently are using 2.3. Let's go to 2.3.2. All right. So let's do my pom.xml. Let's just search for it. 2.3. Let's do 2.3.2. Now, this is when the fun really begins, because what we're going to do now is going to rebuild the project to say, okay, and I'm hoping that I don't have my artifactory set up here. I do. Let's just debug this real quick. Yep. Let me pause sharing for a sec. Yeah. I'm gonna pause sharing real quick.
What are you hiding from us, Matt?
Actually, you know what? This is a good thing to show for like debugging stuff. So I'm going to show you guys how to actually fix stuff like this. So this is Maven, and for those that don't know, Maven is the package manager.
We don't see you. You stopped your share.
I know. I'm pulling it back up.
Just getting another laptop real quick.
Yeah, that's right. There's StreamYard.
Playing Helldivers 2 on another monitor.
I wish. I had whatchamacallit, StreamYard minimized. So, right, let's minimize that again. And then let's go into the terminal. So here's what I'll show you guys how to actually fix this stuff. You have this folder. Maven is a package manager for Java. And it's the mechanism with which you want to install your dependencies, and Maven is the one that handles all this. There's other ones like Gradle and stuff like that, but Maven is the one to actually do that. And sometimes what happens is you have like settings and configurations set up in what's called your .m2 folder. This is where Maven's cache is all set up. So a very, very quick fix, I don't necessarily recommend it, is to just get rid of the repository folder. Like this is like a good quick fix to say, okay, just reset my dependencies. I kind of want to start fresh and start over again with the dependencies, right? So you could do that just by doing simply this. And then I want to also do my settings.xml. If there are any, repositories in here, passwords, they are unable to be used, so nobody worry about that. So I have some Artifactory stuff, but I also should have Maven itself. There we go. Central repository. Good. Okay. So these are all like the repositories that you can like pull down from. And so now let's do that. And let's go back to projects. Projects. Let's go back into Acme monorepo. Let's do that. And let's try this again. Dependencies giving me an error here. What's the error? Missing artifact. Let's try to do. Let's see. Plugin Maven resources and software. Then you know what we'll do now instead. We'll also do .m2. We're going to do that. Let's get rid of the. Here's what we're going to do. We're going to comment out some of the stuff in settings. Don't worry about this stuff. It's not actually real right now. So we have, these are the repositories we're going to pull from. We only want to pull from Maven. So I think it's like this. There we go. It's been a while since I've edited in settings.xml.
Because usually you just use patches and you don't even.
That's true too. Yeah. That's very true too. That's why I have it set up like this, is because so I can use patches. Profiles, snapshots, plugin repositories. Profiles, active profile. Okay.
Watching Matt debug is kind of like watching an like ASMR video. Like, very close to the mic.
I hope it's relaxing for people.
Yeah, if we do this every Friday, just get in the habit of get your coffee, look at watch Matt slowly, spiral into madness.
That's actually not a bad idea, but I want people to see this stuff too, because it's like, it's very true. Settings match tag. Here's what we're going to do. We're going to start fresh. .m2. These are some of the struggles that happen with like dependencies and build time stuff, where like stuff like this can absolutely happen. RF repository, and then you kind of go crazy trying to figure it out. So we're also going to get rid of the settings.xml. Now we may have to use some ChatGPT in a bit here. So let's see though. Desktop projects. And if somebody's in the chat yelling like, "Oh no, do this," then please tell me wrong, because in that way I could stop debugging and start fixing. All right, let's try this again. Install. It's probably going to tell me, "Oh, you don't have a settings.xml." Hey-oh, there we go. See, sometimes all it takes is just delete everything and try again.
It's like, yesterday my wife had this problem on her phone that when she was on the Wi-Fi, everything worked, but when she was on 5G, she could Google things or use WhatsApp, but she couldn't go into any website, and it said that it can't resolve. So I was like, all right, cool, this is a DNS issue, because you can't resolve the the domain can't resolve the IP address, and I was like being fancy and like explaining to her the problem, but then I couldn't fix it, and then I turned off the phone and turned it on again. It was fixed.
And then it worked. Well, you know.
And she was like, "Yeah, that I could have done myself."
I forget what the show is, but it's something about like IT support, and like the joking line is, "Did you turn it on and turn it back on?"
Yeah, IT crowd.
That's
IT
what
crowd,
it is.
yeah.
Yes.
Yeah, there's an episode where he's not allowed to say.
Yeah.
Turn it on, like where they're defusing a bomb, and it's like a Windows PC that is wired to the bomb, and yet he's not allowed to say, "Turn it off and turn it on again."
So funny. Now, here's a pro tip. If you want to see the dependencies installed, you could do MVN dependency tree. I just like to do that, and it'll just print it in the terminal. So now we can see that log4j, we do log4j, you see here, 2.3.2. So this was installed and this was used. So this was the fix that we implemented, was that log4j 2.3.2. Okay. Now, when I actually go to scan it, and oops, where'd it go? Let's do it in the good terminal. And let's do acme on a repo. Let's do C Java. Actually, we can just scan it now. Endor ctl scan -n.demo. Hopefully it hasn't like cached stuff from before. But now that we've actually gone ahead and fixed that those vulnerabilities will be fixed, and there was no indication of a breaking change. So, which obviously we've already found out that it's not a breaking change, right? We were able to build the app successfully and install the dependencies. So that's not a breaking change. Nothing's happened. Where you would see that breaking change is when you would actually go and run Maven install or build your application. Like you'd get a break, like it wouldn't work, what we were seeing before. So the fact that we implemented this upgrade, we went from 2.3 to 2.3.2, we built it, not a breaking change. It worked, which is great. And then we're going to scan again, and knock on wood, these vulnerabilities will be fixed. These 2 criticals, 2 mediums, and 1 low will all be actually remediated there.
Yeah, someone in the chat saying,
yeah,
congrats, good work. Whew. Pat yourself on the back.
Listen, just turn it off and turn it back on again. Just delete everything and reinstall it. It'll work.
Yeah, throw the laptop out the window and get a new one.
Dude, honestly, some days that's what it feels like in grad school when like we were trying to figure out a problem. There were days where I'm like, wonder, if I throw this hard enough, how many pieces will it break into? And I'm hoping for more pieces for it to be broken into, because I hate, it's like the calm, angry insanity kind of thing. That kind of thing. That's usually what it is. So there you go.
I've got to hop, guys, but I definitely learned, if nothing else, turn it off and turn it on again.
All you got to do.
All right. Good talking. See you guys later.
Thanks, Andrew.
See you later. Let's do that pillow one. Where was it? It was, see, we have 14. Now we have 13 kind of thing. Or I have to refresh probably.
So what are we fixing next?
Now we're going to do pillow. We're going to do pillow next. And one quick thing I'm going to do is I'm going to use our internal tool. Actually, let's just do a random project now. Let's do findings. There's actually show you an even better page, Ron. Have you seen this page? Ready? We have a page dedicated to show all the remediations across all your projects within Endor. And you could kind of sort them by remediation risk and, show only reachable remediations or reachable vulnerabilities that remediation would fix.
Kind of like how the findings page does for the vulnerabilities and the reachable ones. So this is for prioritizing the remediation.
That's exactly it. That's exactly it. So we can kind of go here too. We can take a peek at, let's search, it might be case sensitive here. Here we go. So like this is all in that project there. That's still loading. We'll let that load. So this is a low risk. I want to find a breaking change to show that it is high risk. So let's do high to show that like it actually does break. Okay. This is in what? Change detection? PIE. These are the other things that kill me, are the names of these dependencies too. Like they kill me. Like PIE. What does PIE even do? So we could see in this example, if I upgraded from version 11.1 to 12.1.0, there's 2 high confidence. That's like, yeah, this is a breaking change. 2 methods that I used to use, or 2 functions I used to use, are no longer there. So let's actually go into this project. Go into, what is it? Change detection. Okay. Let's do change detection. right? Here's all we're going to do. So this is a real life open source project. Maybe they've actually fixed some of these, but let's find out. What was that PyE one? Here's that PyE one. A couple high versions. So it's currently 11.1. All right, so ready? Let's do, I may actually already have this project. I don't, that's fine. Let's clone it and let's actually try it. Let's do git clone. Let's do that. And then another tutorial on, well, how do I actually build these applications? And this is good to know in case you want to like contribute to these projects. Like, I know it sounds simple, but like read the documentation of like how to actually get this built. And if you want to contribute to it, you actually can, which is nice. So what I like to do is whenever I'm like finding apps to like test, I'll read the documentation on how to actually build it, because if I just use pip install, it may not work. Pip install requirements. They may be using like setup.py or conda. I hope not, but maybe they're using something like that. But okay, here it's like, all right, this is pretty simple. That's how to actually install the dependencies itself or install the component itself. Proxy, raspberries. This is a pretty cool component, actually. So if it's not there, requirements.txt, pretty simple. We'll just do requirements.txt. Readme pip. This is probably how you actually build it. Example use cases. That's how you get it started. Requirements.txt. Where's that PyE? Do they have PyE on here?
Are looking to see if it's declared.
Yeah, it's right there. So it doesn't give an exact.
There's a situation of apps like packages using something that isn't declared in the requirements file.
Yeah, those are phantom dependencies. So you could have a component that's not declared in any of these. Like in here, it is like we have PyE right here. Now there's no version number. So what does that mean? Like everything else, for the most part, has a version number. There's no version numbers. What does that mean? Probably going to use the latest version. So when I scanned this a couple weeks ago, this version of change detection, or however long ago I scanned it, it was using Python was automatically, or pip was automatically bringing in version 11.1. Perhaps what happened was PyE released a new version, they fixed the vulnerabilities, whatever have you. But now I'm curious to see what version actually gets installed when I run pip install requirements in this project itself. So I can go ahead and actually do that. Change detection.io. Thank you. So we could do that. And now we could do pip. I'll do pip3 install requirements.txt. Let's see what happens. I should have started a virtual environment. My machine's going to be a mess now, but whatever. It's already a mess. These things happen. So you can see like Pillow is getting installed. Yeah, ready? So I have to do a virtual environment, Python 3-m. Let's do virtual environment. Virtual environments, for those who don't know, in Python, this is like it is what it sounds like. It's a mini virtual environment that you can install the dependencies in so you don't run into issues like this. Because what happens is this is the classic example of dependency hell of, oh God, well, this version, it depends on that version. This virtual environments, like, get rid of all that nonsense. And it tells you exactly what would be installed if it was like just a fresh computer, or in this case, obviously a virtual environment. So we're going to do source.venv bin activate. So now you can see I'm in my virtual environment here. And now I can do pip3 install requirements.txt. And now instead of it installing it on my machine, it's installing it in the virtual environment instead. So it makes life a lot
Does it not still need those dependencies that you didn't have earlier?
It does still need them, but it installs it in this virtual environment rather than my machine. So my machine
which might have like compatibility issues with them.
Exactly. Like this was like, okay, pips dependency resolver is not currently taken into account all the packages that are installed, of course. PyGitHub requires typing extensions at that, but you have typing extensions here, which is incompatible. This requires this. It's because on my machine, I've just built stuff, and like it's I don't clean up after myself, kind of thing, which I should. So it's like use a virtual environment and it works fine now. So now we can actually do this again. Endor CTL scan. And while that's scanning, I want to check out what version got installed. So what was it? Py? So funny, dude. So 11.1.1 got installed. So Python decided, let's do 11.1.1. That was in the virtual environment. Oh, no. Here, look, see? Because of the virtual environment. It did 12.1.1.
Mm-hmm.
So it automatically did that. Now, you can see here in my non-virtual environment, you have Py 11.1.1. So at a previous date, I scanned this locally, not in a virtual environment, and it picked up Py 11.1.1. However, in the virtual environment where remember, it's like a nice clean environment to install the dependencies, it's installing the quote unquote correct version that the developer intended it to be in their requirements.txt. So we're going to see different results than was already up in there in Endor Labs.
Because it didn't specify, it just went to latest because it didn't specify anything on the requirements.
Yeah, and we can actually confirm that it's the latest version using Endor Labs. So if I actually go ahead, Py, dude, every time I say it, it makes me laugh. We have Py. That's the latest version, 12.1. Now, there's still some vulnerabilities in here, and setup tools, that like pops up all the time. Setup tools in every single dependency. And Tornado has an HTTP cookie parsing DOS vulnerability. Wow. So there are still some vulnerabilities even in the latest version, which is why it's still important to test and scan these and to figure out, well, is it actually dangerous? So we can actually take a look at that. But I'm curious about what findings we're going to find in here. This already finished? Okay, good. So let's see. Some of these are probably test dependencies. So let's get rid of test dependencies. New. Setup tools. So they've actually fixed quite a bit here. So that's good. That's actually very good. You can see here, they fixed a ton since the last version. So that's good. Good job, change detection. Because 2 months ago, you were a little vulnerable. Why don't we do this one? We have a bunch of remediations. Now, this is a damn vulnerable Python web application. This is supposed to be vulnerable. And I think OWASP funds it. But this is a good application if you want to like actually learn more about application security and like how hacking works and like actually exploit some of these vulnerabilities here. So it's actually a good one to take a look at and to go ahead and clone. I'm going to deactivate. What are you doing, terminal? There's that. Let's do git clone. Clone that damn vulnerable web application. And let's then go into that dvpwa. And let's do Python 3m. Let's create a virtual environment. Let's do source. Let's activate it. And now let's do pip install requirements.txt, which is what I saw the docs say, which is good. It's always good when the docs actually tell you how to do it. Now, egg. Well, this is what happens when you use an older app for demonstration purposes. When was the last time there was a commit in here? 7 years ago, 2 years ago? Not a good one. Unless they tell us something. Yeah, Python 3.6 is end of life, so. All right, let's do a different one. Shopping cart might be good. Comfy UI. Let's do my Python video game. And by the way, anybody here can like grab these. This is an open app, and if you want to like, this is public. So if you want to like try this at home, you totally can.
But can they install your video game that you made?
You actually could run it. Yeah, you actually could run it. I think the last time I tried was a few months ago. But like, you got to flip the Krabby Patty. You know, you got to like, what else did I do in it? You do like, you practice karate with Sandy. So it's like you got to karate chop a bunch of times. This was the assignment. Our professor said, okay, I have a 7-year-old and a 9-year-old. I have 2 daughters. They're 7 and 9 years old. I want you all to make a video game in Python, and my kids are going to play it. And if they like it, you get an A. And if they don't like it, you fail. Guy was ruthless. And his kids liked my game, so I got an A. God, guy was ruthless.
That's like borderline not okay.
Yeah, I know, but like he was I learned a ton from him, and he was awesome.
And the kids got a game that they like, so
kids got a game that they liked, and that was it. So it worked. Great, let's do this. And then we're gonna do pip3 install requirements.txt in that virtual environment. Oh no, see? But you have pillow 9. Oh, I didn't activate it. Source. There you go. By the way, this is stuff that happens like if you're using this in a pipeline, all this stuff, this pip install, this happens in the pipeline anyway. This is just locally, so it's just vastly different when it's locally. Okay, cool. So we got my requirements.txt, and now we can do Endor CTL scan. We could scan this one as well. There. Shouldn't take too long. It's not that big of a project, but let's actually look at what is in there. Let's get rid of this and this. Add folder to workspace. Let's do desktop projects. Let's do Python video game. Add that. Like I even add songs in there. So like when you'd win, you make the Krabby Patty. Like the picture would come up and that da 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 da, that whole thing.
I love how proud you are of this game.
Dude, it was a great project. I had a lot of fun making it, man. It was a lot of fun. But let's see what we got in here. So we got Pillow at 9.2. We know that that is a vulnerable version. So let's actually just go to the link here. Okay, good. And now let me pause sharing for one quick second because I'm going to kick off something using our internal tool here. Map demo. Just need to grab this. Because the way our UI works is that we do it like once a day. You can manually trigger it to do as well. Let's just do this. Okay, let's let that run for a minute. Because if we ran it all the time, it would just go like berserk. So let's do. I know I'm not showing anything right now. I'm just going to pull something up real quick.
Next live stream, we're just gonna play your SpongeBob game.
That sounds good to me. No, it's not that good. It's good if you're 7 years old. That's about it.
I mean, my girls are 6. How old are your girls?
One is 1.5. She's actually home because she's sick. Her and I have RSV, which was just great. So 1.5, almost she'll be 2 in March. And then Madeline, that's Emily. Madeline is 4, going on 14. Are your girls like teenagers? Like they're acting like they're teenagers yet? Mine are.
Yeah, it's getting there.
Yeah. I don't know about your kids, but like jackets in the wintertime, we'll never wear them. I don't know. It's always.
It's also, I mean, because we moved here from Israel, and I'm cold all the time.
Yeah.
And my daughters who moved here when they were 4, they're 6 now. They're like locals, you know, like because like right now the sun is out, but it's like I don't know, like 38 degrees using weird American degrees.
Weird American degrees.
So yeah, I mean, so they like you can see the sun. It's basically summer, so short sleeves, and they're not cold.
I don't understand it.
One of my daughters is at home sick now as well, and she like even while at home sick, she's like, no, you know, short pants, short sleeves.
I will never understand it. It's like always like a grind too. It's like, no, you got to put on the shirt. No, I don't want to put on the shirt. Please. No. It's like
for us, it's shoes. Getting them to wear shoes
when
we exit the house. That is when my patience is put to the test for real.
I will tell you what, the thing about patience, my patience has grown so much that it just nothing bothers me anymore.
Then, you know, it's like you have reached nirvana.
Yeah. All right, this one let's try. All right, 9.2 to 9.3. This is the other thing, potential conflicts. You're always going to find potential conflicts. This is we're showing you dependency hell, right? This is a pretty simple app, but you know, some of these the just sheer amount of potential conflicts that you could have like is insane. It could absolutely be insane. So, you know, it's just like another thing to think about when you're trying to upgrade these projects. And this is why when we say like, hey, upgrading is hard, it's super hard upgrading open source dependencies. It's like crazy hard to do.
Yeah. Are we going to do any patches today?
I could try. Maybe, depending on if Artifactory is cooperating. Maybe we save patches for next time. Just because Artifactory, you got to set up some stuff, and we have an instance of Artifactory to do this. Maybe we save that for next Friday, though.
Okay.
I think that'll actually be helpful. All right, let's do this one. Let's do 9.3. Let's do a medium one, actually. Let's take a risk, right? You see more potential conflicts here, right? Break change, we're not seeing any, but let's try this one. So this is a major version change, and there's several potential conflicts, which is why we've given it a medium. But it's a pretty good bang for your buck here. So let's give it a shot. So 10.3. All right, let's do pillow at 10.3. 10.3. No, thank you, VS Code. Okay, so now let's go back into our virtual environment. Cut this off. And let's do install 3 install requirements.txt. Let's see if it breaks. Nope, didn't break. And you can see we've gone ahead and installed Pillow 10.3. Now if we do Endor CTL scan again, those vulnerabilities will be remediated. We might have time for one more. Let's do one more. Let's go back to that monorepo one. That one's pretty good. To go into monorepo. Here we go. Let's try. This is a good one. I want to get like a high breaking change one. I'm in a different project here. Well,
because you want to see something break.
Yeah, I want to see something break to say, yeah, this actually isn't going to work so hot. Oh, you know what? I know which one we can do. I got a good one here. And that will actually set us up nicely next week for patches, where maybe next week what we do is this is a good one. So this uses Jackson Data Bind as one of its components. And if you want to fix a bunch of critical severities, you have to make a change, but it's a breaking change, but we have a patch for it. So I think next week what we'll do is we'll actually show the exploit itself in this and like actually exploit the vulnerability, then apply the patch, and then show that you can't actually exploit it anymore.
Sounds good to me.
For next week. So let's do this. Do I have it in here already? Nice, I do. Okay, so I'll make sure I'm using the right version here. Okay, beautiful. Dependency tree. Okay. 2910. Yeah, I think that's a bad one. Let's go into vuln Spring Boot real quick. Vuln Spring Boot, remediations, check the data bind. 2910.3. That 2910 is the same thing. It'll have the same vulnerabilities. Okay, so ready? Let's try to upgrade it to 217.2 and show that it actually does break. All right, this will be pretty good. So let's do code vuln Spring Boot, not license. Let's open this up, pom.xml. Let's find Jackson data bind. Go. Oh, wait. I know how. It's because it's a transitive dependency, I believe. Or Jackson data bind 2910.3. Maybe using a different version. Hang on. Spring Boot and MVN. Then while we're at it, let's just do cd.m2. Let's just remove the repository folder, start fresh, and then do vn install. Okay. And then we're saying to upgrade to what, 17? To 17.2. Okay. Code palm dot. Okay, good. And we have all that stuff. Where are you, Jackson? Ah. I may have to look at this one again, but you all get the idea.
So what are you looking for now?
Well, I'm just trying. Aha, never mind. Here it is. Got it. So here's Jackson data bind. I was looking at the wrong palm.xml. It was tripping me up. Here's Jackson data bind 2.9.10.3, which is what we're using. We're going to use 2.17.2. And we're going to watch it break. So it built successfully, meaning not a breaking change, 2.17.3. So now if I do that, we're telling you, hey, for 2.17.2, I'll fix that. We're telling you, I could do that. This is a breaking change. Here are the methods that were actually changed that your code was using that now it's going to cause a breaking change.
Mm-hmm.
So now if I try to build this again after doing 2.17.3, and I go in here and I try to do cd vuln spring boot and I try to do mvn install, it should break. I have to clear my M2 cache, but it will break. I can do that. Now I can do this. Projects. See projects. Oops, see desktop, then projects. And spring boot. If I go into the slim demo, cd slim demo, and I do code pom.xml, it should have that Jackson data bind there. Should be a breaking change. Install dskip tests. There it goes. You can see compilation failure. It's because of this version. So it's clearly a breaking change. And we can even probably get that exact method to show up.
Mm-hmm.
Class name ID resolver, type factory, class name ID resolver. And what do you know? Class name ID resolver. It's pretty good.
Mm-hmm.
So now next week, what we're going to do is we're going to apply this patch. We're going to take this application, and actually while I'm in here, I might as well not forget to put this back to 2.9.10.3, which I think is what it was. We'll exploit this app. It will actually show like, yeah, this is an exploitable application. Check this out. I'll perform, I think it's remote code execution using this gadgets component, using these kind of gadgets, they call them, for deserialization.
Mm-hmm.
we'll exploit it, and then we'll take the patch, we'll show that whole flow, and we'll actually apply the patch and show that it does not break anything, but it like fixes this kind of really bad vulnerability. Not kind of really bad, it is really bad vulnerability.
Okay.
That's what I'm thinking.
Yeah, sounds good to me. Well, this has been great. At least I learned something about the daily plight of a developer trying to fix open source
Dependency help, man. That's what we're trying to help, is to get you out of there.
It's real. It's real. All right. Hope you feel better.
Thank you.
Go relax, play some Helldivers.
I wish. If anybody, are there patches? Yes. All the patches are human reviewed. Yep. There's a bunch of automate. We're essentially just backporting the fix from a later version. And then we provide reproducible builds, all the test logs, but they are indeed human reviewed, because otherwise they'd break all the time.
Yeah. We were talking about it earlier. I think you just joined when we were talking about AI and LLMs and how we've almost like come full circle on
great, isn't it?
On it being like a a benefit or a detriment. All right, cool. So thanks for joining, Matt. Andrew is logged off, but I'll give him some kudos for jumping on, talking to me about patches. Yeah, and we'll do this again next week, same time. Do you want to do like today, or do you want to do 1 p.m. Eastern?
Yeah. I'll tell you. Do I have anything? What's the next week? This sounds fine. Yeah. Either one, honestly. Either one.
Okay.
Whatever people want.
The Ron and Matt podcast. Listen, I can even play us out with some music. You like that?
I love that. I'll set up my RGB too, so it I got these like hexalights and everything. Yeah. So I'll set these up so they give like good color.
Oh, you're a real streamer now.
I'm getting there. I'm getting there.
All right. Thanks everybody.
Thanks all. Thank you. Yeah.